Okay, hi Khawla. So as I promised you, I will explain to you the time that we lost in our last lesson. So we talked about the electrical force, and in this video, I will explain it as simple as I can. So the electric force, most important thing on it, the electrical force. The most important thing that you need to know is Coulomb's law. So Coulomb's law. What is Coulomb's law? Coulomb's law basically is F is equal to K Q1 Q2 divided by R squared. What does this mean? What is F? What is that and this? So F is the electrostatic force. So it is الكهرباء الساكنة أو قوة الكهرباء الساكنة. K is a constant which is ثابت. Q1 and Q2 is the charges الشحنات. R square is the distance. Taking here. Okay. المسافة بين الشحنتين. So this is the most important thing that you have to know, and you must know that if we use Newton, the unit for it is Newton. So here is the units. We use Newton for F, and for K, since it's a constant, we will use Newton times meter squared per coulomb square. And for the charges, charge Q, we will use coulomb. And finally for the R, we will use meter. This is the SI unit that we will use for each quantity you will study in Coulomb's law. So we know that. Then you must know that we have two different types of charges. Okay, we have plus charge and we have minus charge. You have to know that if I have plus and minus, they will attract each other. So they will win toward each other. Then if I have minus and plus, same thing. They will attract each other. They will their direction will be toward each other. And then if I have minus and minus, the same charge, they will repel each other. So Q1 will be upward, Q2 will be down. Then if I have plus and plus, same thing, they will repel each other. This one, for example, Q1, Q2. If I am asked to determine the direction of the force that Q1 is exerted in Q2 and Q1, then the force will be upward. Why upward? You're saying that Q2 is going downward. Yes, but the force that exerted on Q1, it will be up. That's why the Q1 is going up. Same thing if I'm asking you what is the force that Q1 exerted on Q2, you will say yes, Q1 is going up, but the force that exerted on Q2 is going down. It's going down. Okay, those are the most important things that you have to know on the electric force. You have to know Coulomb's law, electrostatic force, and then you have to know each one or each quantity. What does it mean? We say this is the force, this is a constant, this is a charge, and this is the distance between the charges. And then you have to know that there is a plus and minus charge, and when they will be attracted to each other, when will repel each other. Okay, and here is something important. You have to know K. What does K equal to? K is 9 times 10 to 9. This is the quantity of K. Sometimes they will say 8.99, which is 9 times 10 to 9. Okay. I noted that in most of the questions that you sent me in your presentation, there is something you have to know, which is al-badi'at. It's something basic that you have to know. I noticed that they are, for example, giving you Q is equal to 4 microcoulomb, or they are giving you Q is equal to 2 M coulomb. What does this mean? You have to transfer the unit to the SI unit. And you studied, I will give you some example, and I will insert a picture of al-badi'at so you can use. Micro actually is equal to 10. Micro is equal to 10 us minus 6. Okay, and M is equal to 10 us minus 3. And you have some too. You have, for example, femto and nano, milli, micro, and all this I will insert it to you. So I saw those two. You have to transfer the unit. For example, you said that Q is equal to 4 times 10 to minus 6 because you transfer it. And then you will say Q is equal to 2 times 10 us minus 3 coulomb. Coulomb, you transfer it from M coulomb to coulomb. Okay? Okay, so now I will move to some examples. The first example, you have, it's number 1, I think. Yeah, you could watch it on your presentation. It's minus 4 minus 4 microcoulomb charge lies on 20 centimeter. It says 20 centimeter to the right of a 2 microcoulomb. He gave me another charge 2 microcoulomb on the x-axis as shown below. So the question is, what is the force on the 2 microcoulomb charge? So let me organize. So this one, the first one will be Q1. Here I have R, and here I have Q2. Remember that the minus of the charge, I'm not gonna put it on the law, on Coulomb's law, but I will use it to know which direction is going. So I have here Q1. It says that I have a charge lies 20 centimeter off the right. So here I have Q2, and here I have Q1. To the right, it says to the right. Okay, and I say that Q1 is minus 4 microcoulomb, and this one is plus 2 microcoulomb. So plus and minus, they will attract each other. So this one is going toward Q2. The distance between them is 20 centimeters. In this case, I could just solve it without transform it, but I will transform it so you could understand, or to get it on the SI unit. So Q1 will be 4 times 10 is minus 6, because this one is micro, because this one is microcoulomb. So here is micro, here is micro, so it will be 2 minus 6. This one is centimeter. Centimeter is, so let me do Q1, Q2. It's going to be 2 times 10 to minus 6 coulomb. I got it in coulomb. Then R is going to be 20 times 10 to minus 2 meter, because the centimeter is 10 to minus 2. Okay, so I transform it. Now I will start using Coulomb's law. This is my information that I got. Then I will write Coulomb's law, which is K is equal to Q1 Q2 divided by R square. I know that K is equal to 9 times 10 to 9. I got everything, so now it's just a calculation. 9 times 10 to 9. Q1 is 4 times 10 to minus 6. Q2 is 2 times 10 to minus 6 divided by R square, which is 20. And now using the calculation, I will get okay, so it is going to be 10